if x raised to the power of 3 plus y raised to the power of 3 equals to 3xy, find the y all over the x. Now write solution. Our x raised to the power of 3 plus y raised to the power of 3 equals to 3xy. Amen? Okay? Note that this is an implicit function. So what we will do, we are going to apply this method. We'll now write d all over the x, all in bracket, x raised to the power of 3, amen, okay, plus d all over the x, all in bracket, y raised to the power of 3, and this is equals to d all in bracket, that is d all over the x, all in bracket, 3xy, amen. So this implies that you should differentiate what is inside the brackets. So let us differentiate x raised to the power of 3. If we differentiate x raised to the power of 3, we'll have 3x raised to the power of 2 dx all over the x. Why dx? It implies that you differentiated for x. That is why we are having dx all over the x. Amen? Then, plus, we are going to apply the same thing here. If we differentiate y raised to the power of 3, we have 3y raised to the power of 2 dy all over the x. Why? Because here we differentiated for y. That is why we are having the y all over the x. Now, we have equals to 3xy. Amen? Okay? So this implies that either you first differentiate for x or you go for y. Are you following? Okay, so if you agree with me, let us first differentiate for x. It means we are going to hold 3y constant, just like, look at it this way. If we want to differentiate for x, definitely we are going to hold 3y constant. Then any value obtained, we use it to multiply the constant. Amen? Okay? So if you agree with me, let us differentiate x. It means we are going to hold 3y constant. Amen? So if we differentiate for x, ordinarily we are going to have 1. Amen? So if we use 1 to multiply this constant 3y, it means it will give us 3y dx all over dx. Amen? Are you following? Because we differentiated for x, so we obtain this. Now, what is the operation in front of this? It is positive, true or false? So it will be plus. It implies that it is the term for y, because we have two functions here. We have x and y. So since we want to differentiate for y, it means we are going to hold 3x constant. That is, if we are asked to differentiate 3yx and want to differentiate for y, it implies that we are going to hold 3x constant, then we differentiate for y. Amen? Any result we have, we are going to use to multiply these constants. Do you agree with me? Okay, so let's differentiate y if we differentiate y, ordinarily we will still have 1. So if we use 1 to multiply 3x, it implies that we are going to have 3x dy because we differentiated for y all over the x. Amen? Okay? So, looking at this equation, I want to show us something. If you agree with me, if we have a all over a, this is the same thing as what? 1. Amen? Then what if we have x all over x? This is the same thing as 1. Amen? Okay, what if we have the x all over the x? It's the same thing as 1. Do you agree with me? Okay? So if you can see what I am saying, this guy and this guy will cancel. And this guy and this guy will cancel. Amen? So this is, we can write this equation this way. 3x raised to the power 2 plus 3y squared dy all over the x. And this is equals to, since this guy and this guy has cancelled, we are going to have 3y plus 3x dy all over the x. Amen? Do you agree with me? Okay? So at this point, we are going to collect like terms. Look at the question. It said, if this is equals to this, it said find dy all over the x. Okay? So if you agree with me, at this point, we'll collect like terms by writing this equation in this form. We have 3y squared dy all over the x. Amen? Then if this guy crosses the sign of this equality, it becomes minus. Do you agree with me? So we have 3x dy all over the x, which is equals to 3y. Then this guy, 3x raised to the power of 2, crosses the sign of this equality, becomes minus 3x squared. Amen? Okay. Let's look at the left hand side. Let's look at the left hand side. We know that we can factorize this left hand side this way by bringing dy all over the x outside. Then we write 3y squared minus 3x all in bracket equals to 3y minus 3x squared. Amen? Do you agree with me? Okay? So if you agree with me, it implies that we divide through by this guy. That is, divide through by this guy, 3y raised to the power 2 minus 3x. If we divide through by this guy, it means we are going to have 3y squared minus 3x all over 3y squared minus 3x. Then this guy and this guy will go. Amen? So if you agree with me, the left hand side will be left with dy all over the x, which is equals to 3y minus 3x squared all over 3y squared minus 3x. Amen? Okay. If you can see what I am saying, we can still break this guy down. Amen? By writing, we can write this equation this way. 3 all in bracket y minus x squared all over the same thing applicable 3 all in bracket y squared minus x. Okay, so this and this will go. Amen. So therefore our dy all over the x is equals to y minus x squared all over y squared minus x squared. Amen. This is the final answer. Any question? If there is no question, okay.